back again. Not as hot as last year, which is good, but I'm still been hanging out near the air conditioning unit. I'm obviously joined by my very, very good friend over at Supermicro, Alok, who's going to be essentially helping me break down this monolithic idea that is AI factories and this kind of next generation of revolution. And so essentially for me, I'll be covering the macroeconomic scales, looking at the general global footprint that this kind of AI scale is going to mean for us. And Alok's very kindly going to talk a little bit more about why we're looking at that kind of growth and that kind of scale. So I don't actually have a clicker. I'll get started. If someone can bring me one, that would be wonderful. So I'll be honest, it's a big stage. Alok, you've presented with me before. I like to have a bit of a mince about on the side, to make use of the space is what they say. So I was thinking really interestingly about the scale of these kind of AI factories. Now, there is a little bit of a misnomer about what necessarily an AI factory is. And I think it falls into one or two camps, right? One of which is it a factory that uses AI to implement what a traditional factory would do? Or in and of itself, is it a factory specifically for AI? Well, it's kind of both. And so what I really want to do is kind of look at what we've done in the past, what we've done in the future, and what this necessarily means for you guys. So AI factories are essentially a blueprint where if we look at a traditional factory from a car company, let's say like Jaguar Land Rover, who are just here, and let's say they're opening up into new markets, they want to build a factory in Singapore, is that going to be vastly different to the factory that we have here in the UK or in Germany or in the States? Probably not, right? There's going to be some minor changes about the physical ground space and a slight layout, but essentially it's a copy and paste. And that's what AI factories is. It's looking at how do we take what we look at now when we look at an AI platform or an appliance or a small rack in a data center and scale that out to a global investment. And you will see lots of news at the moment about investments in AI factories and this revolution. And one of the things I kind of really wanted to look at was, how's that possible? If we look at what an AI factory requires, it's that of essentially a small city. If you look at the difficulties of planning a city, when we talk about multiple megawatts of power, we're talking about infrastructure, whether that be roads or cabling, plumbing, you name it. It's a pretty wide and big investment. And one of the things I used to love as a kid was the idea of Bourneville. If you're not familiar with Bourneville, essentially Cadbury built a town to service their chocolate factory. Obviously, as a child, I imagined this a little bit like Charlie and the Chocolate Factory, and you'd wake up, head to the local bakery, it'd be chocolate for breakfast, work at the chocolate factory, chocolate for lunch, chocolate for dinner, home for chocolate. But actually what it was bringing the infrastructure to the factory, not the factory to the infrastructure. And that's what we are very likely to see when we talk about this new revolution of AI factories and the scale that they're at. We will need to essentially build from scratch. We will need to be looking at building it better than what we've done. So one of the really, really interesting parts of this is going to be the kind of footprints of these factories. And we look at AI and we go, okay, data scientists and data visualization and people like myself who are sort of hardware jockeys, infrastructure guys, right? But it's so much more than that. Alok's going to talk a little bit about things like liquid cooling as well, and that's going to require, huge amount of input from city planners in terms of how do we get that water to the AI factory or data center? How are we able to deliver product to the factory in terms of roads and potentially airstrips? How are we going to power a 5 megawatt data center, which essentially will be using the same amount of power as a city like Birmingham? What's going to happen when we drop 7 new Birminghams on the UK, right? It's a lot of infrastructure. And we've seen these changes before at this kind of a scale. I think lots of people will talk to you about the implementation of something like, let's say, the Industrial Revolution, right? Revolution 2.0. And then the Internet Revolution or the Information Revolution. And if you could go back to before the Industrial Revolution, what would you do better? What would you do in hindsight, right? It's very easy to look back and say, what would we do? Well, I think one of them would probably be looking at it from an economic scale, specifically on how much fossil fuel we'd necessarily need to be using in that part, and look at how we could do that more economically, more eco-friendly, and then also probably, things like workers' rights, right? In the Industrial Revolution, it wasn't exactly the typical case that a worker would have, medical benefits or pension or anything like that, right? So we've got this opportunity now to start planning for these infrastructures and start looking at that kind of a scale, because it will take a lot for us to get there. And I think a lot of people are talking about how is AI necessarily going to take jobs? How is AI going to replace us? Well, it's not here yet. We do actually need to build the thing first before it might start taking our jobs. But at least at that point, there is a requirement for those builders, those plumbers, those electricians. We're also looking at that kind of style of a ecosystem built around that I call it the Bourneville architecture or the Bourneville blueprint, where we can create a unified system that allows AI and humanity essentially to coalesce into one individual iteration of a civilization as it was. I think the other side of things, right, in terms of a paradigm shift is the introduction of the internet and the information revolution. Now, there was this incredible interview. I recommend everybody here today to go on YouTube when you get home and look it up. It's with a big hero of mine, David Bowie. And he was essentially asked what he thought of the internet. And the interviewer says, it's just a tool to get information. This is in the early 90s, just as we're talking about dial-up modems. And Bowie kind of turns around and says, actually, it's not. It's this conglomerate of ideas. It's a monster. It's a beast that, no one's necessarily going to be able to tame. It's going to move. It's going to shift. It's going to be an entity all in and of itself. This is a man who said this at the times where you'd be playing video games with your friends online, and you'd have to shout at your mum not to answer the phone, right? And this guy could see 15, 20 years into the future. So again, what would we do if we could go back around? And before this internet revolution, before the kind of start of social media, I think that's kind of let's call it a revolution 3.5. I think you would probably go back and say, well, we should really be thinking about, people's data, talking about sovereignty. We should be really looking at how do we protect the users over necessarily the people who house this stuff. And I think a lot of people tend to think that AI is at odds with these ideas. If anything, they actually kind of work very well together. If I look at that and I look at, accessibility of AI, this is a really, really big point to allow those users to have their rights and have accessibility. And we're talking about commoditization on a global scale. We're talking about hundreds, if not billions of dollars for an individual factory. How do you commoditize that to the average person? And how does that work with being economic? I think a lot of the time we will rush for commodity, and you'll see it now that there's a lot of disposability in what we do economically. It's very strange. I was at my nan's house, and we were eating strawberries. I go to chuck the punnet in the bin, and she says, no, don't chuck it out. I go, oh, sorry, recycling. Go to put it in, no, washes it out. I go back 3 weeks later, and she's using it to hold the seeds for the garden. And you go and open a cupboard, there's about 4 other punnets in there as well. It's this very strange kind of use of something that essentially is rubbish, is disposable, it's very economically efficient for us, but it's not very economical for the planet. Now, I think with AI, what we want to be making sure is that when we talk about commoditization of AI, it's about accessibility, not disposability. We don't want to have the infrastructure be so commoditized that it's cheaper to get rid of it and replace it than it necessarily is to get it back up and running again and fix it. And I think AI can be used, and it will be used in this snowball manner where we need to hit, as I said, a point where we can power something the size of Birmingham in about 1/10 of the space of it. AI is going to be key in allowing us to get there and do it, and you'll start to see, and Alok will talk about this a little bit more, this rolling effect, this snowballing effect where what AI is putting into itself, it's also getting out, and I know that worries some people. You know, Skynet gets thrown around every now and then in conversations. But it's what is going to allow us to hit that idea of a unified blueprint for AI at a factory scale and a global scale. So what I want to do is pass over to Alok, who's going to talk a little bit about why we're seeing that kind of growth within AI and why are we having these kinds of conversation. Are we there yet? Are we not there yet? How are we going? Alok, please, my friend.
Thank you. Yeah. Thanks, Josh. So that was awesome. In fact, as Josh mentioned, it's a paradigm shift. And as you all might know, that each paradigm shift is followed by inflection points. So the very first inflection point that we experienced in this industry was at the end of year 2022 when OpenAI, they introduced ChatGPT. That is also considered as the watershed moment in the field of artificial intelligence. The reason is obvious because it pretty much changed the whole paradigm, how the computing was perceived for last 60 years. And with this new one now, human language is the new programming language, large language model is the new platform, and generative AI is the new app. So this shift pretty much forced all the industries to plan their future and their present, taking into consideration the generative AI. So this is how this has started. And because every industry tried to re-strategize themselves, so that's why it is also referred as a strategic inflection point. So this was the first one. The very second one, then it happened after a couple of years. There was significant improvement that was made in this particular field, and then we came across the second inflection point. And this is also referred as a DeepSeek moment, when everybody realized the capabilities and the power of reasoning models. And with this reasoning model, this is very important and plays a very vital role, especially for this generative AI, because with reasoning model, what you do, what it can do basically is, for AI factories, this is the foundation. And what it can do basically, it reasons through. It is not simply about generating the tokens, what used to be the case. It is not simply generating the tokens, but it reasons through those tokens, and then it will provide you with the best possible answer to your query, and in the most efficient way. So this is what has started happening, and this gave, in fact, a very big boost for AI factories for their implementation. And this is happening at a very, very fast pace now. And now it is all about, not simply about generating the tokens, but it is about generating the tokens, the quality tokens, at a very economical price. Economy is also going to play a very important role for generating these tokens. So this is very important. And then, with this adoption is skyrocketed. And now pretty much you can see that everywhere, not only simply about the industry verticals and the commercial side of it, but even at the country level, this is happening a lot. In fact, in Europe is building 7 AI factories across 17 EU nations. And the way things are moving, pretty soon, in a couple of years, you will see it will be other way around. There will be 17 AI factories that will be built for 7 EU nations. So this is the pace at which things are moving. There are some other countries as well, India, Japan, and of course, Norway. They made some significant progress in this particular field. So the most important thing is that this is one of the most complex problems right now in front of this industry, what everybody is trying to solve. For AI factories, not simply generating the tokens, but generating the tokens, the quality tokens in the most optimized way. And that is where Supermicro comes into picture, because we are very proud to say that at Supermicro, we have done world's largest deployments in this particular field. Some of them, they are open secret. You all might know X.AI, that was done by us, and it is one of the biggest consolidated GPU, that is 100,000 GPUs cluster for this type of deployment. And that, not only we did that, but we did that in record time. That is 122 days. The day we received PO, and finally the cluster was handed over to X.AI. So here, in this particular field, what happened because of this, our experience, since this is a very complex problem, so we tried to simplify it as much as we can, and we came up with this idea of DCBBS. So this stands for Data Center Building Blocks. So here, Data Center Building Blocks stands for, basically it's the body of work what we do at Supermicro in terms of AI infrastructure, and that is computing, networking, storage, and services, software, and last but not least, that is liquid cooling. So that's what we do, and it's a bundle, just one single SKU, because right now, lots and lots of deployment that we are doing, that is from scratch. And for those type of deployment, this helps us a lot to communicate with customers in the most efficient and in the simplest way. The biggest system right now, you all might be aware, that is GB200 NVL72. So right now, the theoretical limits, what this is capable of doing is creating a cluster of 6,144 nodes, and that to GB200 NVL72, where each node is a rack. So this rack, the one that you see at the extreme left, or my left, your right, yeah, my right, in fact. So this particular system, so this is the system, one of the most advanced system that is available in this industry right now. And you can create a cluster up to 6,144 nodes. So that translates to around 442,368 GPUs. So this is the limit where things are moving now. And each rack is capable of generating up to 1 exascale of compute power. So you can imagine to what extent this can go. So this is what we are doing at Supermicro. So this pretty much sets the stage for the next big thing that is happening now. The things are moving in that direction. That is the Revolution 4.0. That is going to be the industrial revolution, one of the biggest industry. And pretty soon you will see that each industry will have 2 factories. The first factory is, of course, the physical factory, where things are manufactured. The second one is going to be AI factory. Not only this, there is going to be a third unit as well, that is your digital twin. So these 3 things will work seamlessly to expedite this or to accelerate this heavy industrial revolution, which has already started shaping the world. The early signs you can see. The most important one is the Hopper GPU. You all might be aware of that one. That was one of the most advanced chip, but now, of course, it is Blackwell. So Hopper was the first chip, very advanced chip, that was not simply done by NVIDIA engineers, but it was co-designed with AI as well. So it was, if you will, it was designed by NVIDIA engineers and AI. So AI played a very vital role, and here you can see the circle completes. AI is helping GPU, and GPU is helping AI. So it's a full circle thing. The next very important thing for this heavy industry, that is robotic arm, robots, and all this stuff. So for that also, it is getting accelerated, the deployments and all this stuff. All this stuff is happening because of again digital twins. So what you can do, you can create a digital replica of your actual factory floor, and on the digital replica, you can train a robot. This is one very high-level example. There are lots and lots of details involved in this one. But at a very high level, you can train that robot on your digital factory floor. And once it is trained and it is working exactly according to your needs, you can take that software, put it on the actual robot, on the actual factory floor. And with little to no learning curve, it will be up and running. So this is how, in future, you will see the fleet of robots will be created for this heavy industries, and this is going to expedite this revolution at a very, very fast pace. The most important thing right now, so far, the visual computing is going to play a very important role. So far, the notion was that visual computing is mainly confined to media and entertainment or the gaming industry, but that is not true. In this particular case, you will see the visual computing is going to play a very, very vital role. And this is, the heavy industry, this is, according to research, this is one of the biggest industry, $50 trillion industry. So you can imagine that industry is there, which is going to be the next big thing. And how big of an opportunity is there to grab now. So ultimately, finally, what the vision is right now, that for very sophisticated type of deployments or the manufacturing units, it will be fully autonomous AI factories. And this is how it is going to be, because these three things, what I just mentioned, your physical factory floor, your digital twin, and also the AI factory, they will work seamlessly. And as a result, what you will see that there will be very little human intervention, and there will be no humans involved in the operation, but still you are getting the most optimized, highly sophisticated products done by this type of industry. So this is the final path where things are moving at this point. And as of today, pretty much you can say the two industries, they are power users of AI. First is, of course, semiconductor industry. Second is the auto industry. So these two industries, they are power users of AI. They are doing pretty well. They're making the best use of AI, what we are talking about right now. In case of autonomous auto industry, you can see pretty much from design to final product, they are using AI a lot. And in each and every step, they are using AI and the digital twins and all this stuff. And the end result is they are producing very good robots. And what I mean by robot, your cars. The most, the latest cars, what you see, they have this autonomous driving feature, so that pretty much makes it a robot. So your new car is a robot now, because with little to no human intervention, now the car will drive on its own. So this is just the starting point, but in number of other verticals also, you will see these type of things will be happening, and the robots, they will be pretty much, autonomous robots. Here, one very important thing I would like to mention, this also calls for a very specific type of infrastructure. And at Supermicro, we work very closely with NVIDIA, and we do have this end-to-end solution. The one very important thing about this solution is that it includes your RTX Pro 6000. This is, again, a GPU, very sophisticated and very important GPU for these type of deployments. The beauty of this GPU is that each pixel, what it calculates, there are 15 pixels that is generated by AI. So again, here at this point also, GPU is helping AI, and AI is helping GPU. So again, it's a full circle. And the end result is your robot, that is your car. These two industries, they are doing really, really well, especially the semiconductor industry and auto industry. But the next one that is coming up very fast, that is healthcare industry. So in healthcare industry also, you might have seen the drug discovery and the personalized medicine and also the robotic-assisted surgeries. These are playing a very, very important role, and AI is helping them a lot. So first of all, for drug discovery, the time to market right now is around 10 years. So that time to market, that will be shortened. That will be shortened. That is the first stage. And then the second, there are a number of diseases that are very, very, they need this type of personalized medicine for the best results. That is also happening. And robotic-assisted surgeries, that is also happening, where you can see that robots are performing surgeries with a very, very big precision, and the results are amazing. So all that stuff is happening, but the most important part here is, for drug discovery, you need to do some chemical calculations, which is currently not available. Whatever infrastructure we have, that's a great infrastructure, but that is not good enough for those type of calculations. So that's where you will see that that the next big thing that is happening now, that is quantum computing. So quantum computing, in last year, it made a very good progress. And you will see that with the help of quantum computing, especially these three industries, these three verticals, I should say, the one is chemistry, biosciences, and material sciences, they will gain lots and lots of momentum. The type of data that it is looking for that can be produced with this quantum computing, because with quantum computing, you can generate very very high quality data, and that data can be in turn used for training your models. So this is how you will see that all these 2-3 verticals, you will see lots and lots of improvement in next couple of years. So, having said that, one very important thing, again, I would like to mention here is lots and lots of development is being done here, and things are moving at a very, very fast pace. Your models, they are getting very, very complex, very complicated models, and they are doing some amazing work. So right now, we know this model what a model can do, but it is equally important to understand why and how this model can perform this way. So why and how is more important now, rather than what it is capable of doing. This way, this is the only way that, okay, now humans can take control of these models. Otherwise, pretty soon, models will go out of our hands. So this is one area where lots and lots of work is already being done, and it is still in progress. It is still in infancy, and that is called mechanistic interpretability. So by that, they are trying to understand the behavior of model, and that's the only way the model it can be controlled, and the transparency, the security for the next phase can be maintained. So all this stuff is happening at a very fast pace. And when we talk about fast pace, so it is not simply about speed, but it is about speed in the right direction, that is velocity. And we are proud partner of Boston, with Boston, Supermicro and Boston. They are partner for around 30 years now. We have done some amazing work in the past, and we are all set to do even better in the near future. So at that note, I pass it back to Josh.
Perfect, thank you. Although I think it sounds like time, so
I'm loitering in a menacing fashion.
Yeah, I know.
I'll let you say a couple of final words.
Well, my final words are this. I could do with a gin and tonic. We've got some drinks over at the Boston booth now. If you just head over to the other side, we've got a suite, air-conditioned to the nines. Please, you are very welcome.
You're taking away my audience. But enjoy.